Let's make a slope field which is more likely to be seen on the AP exam. When they give you a slope field to do, quite often they max you out at about 12 points that they're interested in. So we want to construct the slope field for the diffie x plus y. All right, dy dx equals x plus y, and then sketch a graph of the particular solution that passes through the point 1, 2. Now in the previous slope field that we made, we saw that there was repetition vertically. And in fact, it can be proven that if only an x value appears in the differential equation, you're going to have vertical repetition. If only a y value appears, then you can have horizontal repetition. And if you've got both x and y, then the potential for repetition is there, but it's a little bit harder to determine. But there is some repetition. Let's see if we can find it. So again, we got our three columns, x, y, and dy dx. We can start with the origin again, 0, 0. So we have x and y are both 0, and 0 plus 0 is 0. Let's go to the rest of the points on the y-axis. So over 0, up 1, over 0, up 2, over 0, down 1. Again, the derivative is just x plus y. 0 plus 1 is 1. 0 plus 2 is 2. 0 plus negative 1 is negative 1. Now let's take a look at this point. That's over 1 up 0. So we have 1 up 0. And then we also have 1 over 1 up 1, over 1 up 2, and over 1 down 1. That's that point right there. So if we, again, calculate dy dx, we're doing x plus y. 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus negative 1 is 0. And now we get to our last 4 points. This is negative 1, 0. Then we also have negative 1, 1, negative 1, 2, and finally negative 1, negative 1. Okay, so negative 1 plus 0 is negative 1. Negative 1 plus 1 is 0. Negative 1 plus 2 is 1. Negative 1 plus negative 1 is negative 2. So now that we have all these dy dx values, let's draw our slopes. So again, at the origin, slope of 0. And then above that, slope of 1. And again, right about there, and then a slope of 2. And over 0 down 1 has a slope of negative 1. Okay. Now we have this column right here. Over 1 up 0 has a slope of 1. Over 1 up 1 has a slope of 2. Over 1 up 2 has a slope of 3. Over 1 down 1 has a slope of 0. Right? And finally we have this column right here, negative 1, 0, back 1 up 0, negative 1. Back 1 up 1, 0. Back 1 up 2, 1. Back 1 down 1, negative 2. Okay, couple of points to take a look at. First of all, the repetition. Notice this time the repetition came diagonally, right? And once you see that repetition happening, you can continue the repetition on and kind of get the slope field drawn a little quicker. Second thing, when it comes to grading a slope field, if they make you draw a slope field, they're going to be checking on whether or not you have 0 slopes where they should be, and if you have positive slopes where they should be, and negative slopes where they should be. They're not going to actually look and say, oh, you know what, this actually doesn't look like a slope of 3. It's more like 3.2. Doesn't work that way, okay? What they may do is say, well, this is a slope of 3, or supposed to be a slope of 3. This is supposed to be slopes of 2. Is this line steeper than those two lines? Well, it is? Okay. So you have shown that you know, even if you didn't go over 1 and up 3, you went over 1 and up, 2.9. They're not going to get out their rulers and their protractors to measure and see whether or not your slope is 100% correct. But they do want to see that a slope of 2 is steeper than a slope of 1, and a slope of negative 2 is steeper than a slope of negative 1. Right. So there's your slope field. That's all we're looking for when we're creating it. As far as sketching a graph of the particular solution, well, start with the point we're interested in, over 1 up 2. And now we're going to let the little slopes guide where we go. So we have to start with this slope. But when we get to that diagonal right there underneath the pencil, now the slope should only be negative, or it should be 1. So we got to kind of make it less steep. All right, notice that my slope on my red line right there is equal to all the slopes. It doesn't have to go through the points. Okay. Now when I get to this diagonal right here, I need my slope to be 0. All right. So when I get to that point, I need to be leveling off. So again, if I put my pencil back, notice the red part of the curve that's underneath the pencil is flat. It's 0 slope, just like all the other slopes. And then finally, once I get here, now I can see that my slope is guiding up in that direction.